Yes, carry on. Last one question related to
Yes,
your
sir.
PhD topic. Yes, no?
Yes, sir.
Yes, main group OMC chemistry. Yes, what the basic application of main group?
Sir, generally we know main group metals are highly reactive and difficult to handle, so it's more challenging to work with this. This is the first. Then here we try to synthesize using main group elements. We try to synthesize catalyst which further used for the different type of reactions like hydroboration, hydrosilylation, all these. And from these some materials, polymers are also used using these organometallic compounds.
Yes, any drawback, limitation, yeah, challenges in your PhD topic?
Yes, sir. Most challenging is, as I said, it is highly air and moisture sensitive. Whenever we try to expose this compound, somehow it will expose or some air may be inserted into this compound, it will immediately decompose. So it's very challenging to handle this. While handling, we use a special type of equipments like slant tubes. Here we try to manage it with a nitrogen atmosphere using slant line, and it is difficult to take the mass and NMR also, because whenever we try to fill these compounds into NMR tube for NMR, due to mishandling it suddenly decompose, or if air or some water vapor enters into it, it decompose and our whole compound will destroy, sir. So handling is more important in this field.
Yes. Next, move on your OPSC organization. Yes, what the basic history of
Yes,
OPSC
sir.
organization?
Sir, OPSC is Odisha Public Service Commission, sir. Uh, they give job to the people for development of Odisha. There are various departments like civil service, Odisha civil service departments are also there. They also mining department, educations department. They rule all over all the departments of Odisha.
Yeah, next is why will you become a assistant chemist in OPSC organization? Why you want to join?
Sir, as like my uh, a whole career journey, I like chemistry, so that I started my journey with chemistry, and now I am continuing my PhD. This I thought this job is more appropriate to apply my knowledge and my experience in this field, sir. It matches with my interest and my academic career, sir.
Yes. What the role of assistant chemist in OPSC? What are the major responsibilities of assistant chemist in OPSC?
Sir, assistant chemists work under the senior chemist, sir. Their role is to do experiment in lab. This post is for mines, steel and mines industry. So here they has major role like sample collection, identifying the ores and analysis of ores. All these things they can did by doing chemical experiments in laboratories.
Yes, suppose if you get selected in this post, then what do you do?
Sorry, sir, I can't hear.
Yes, if you get selected in this post, then what do you do?
Sir, if I got selected in this post, then I honestly do my job, and I always try to listen and follow the senior chemist instructions, and I did my best to work on this.
Next, suppose if you get selected in this post, then how will you contribute your MSc project knowledge in your department? What are the innovative idea from your side? And also PhD.
Sir, based on my MSCs, I already told that my MSc project is based on the and majorly the biological applications, the anti-cancer activities. But sir, this job is for mining and steel industry, so I thought this is not much applicable in this field. But I can use my PhD experience of 1 year in that field. In my PhD life, I can know. I already told that I handle the more air and moisture sensitive. If I can handle the sensitive things, then I can easily manage the air stable and normal things. This is my expertise, special expertise than other people.
Yes, good. The next move on chemistry sections.
Yes,
Yes,
sir.
chemistry in organic and physical and spectro.
Yes, sir.
Yes, first is chemistry. What are the basic application of chemistry?
Sir, chemistry means the finding the reason behind anything happen around us. Sorry, sir. Actually, I get a call from my supervisor. Can I
Okay, sure. No problem.
just? Sorry, sir.
Yes. Now
Am
fine.
I audible, sir?
Yes,
Yes,
only.
sir. I'm fine.
The next move on chemistry section. What the basic application of chemistry?
Sir, in our daily life, everything is has a chemistry application. Like the clothes we wear, the food we eat, in everything, every process, every everything is uh, behind everything. Chemistry is there, sir.
Yes. First is inorganic chemistry. What the basic application of inorganic chemistry?
The inorganic chemistry is mainly deals with the metals and ions of the chemistry. Inorganic chemistry is under inorganic chemistry, various branches are there like coordination chemistry, organometallic chemistry, uh, mm, our a block transition metals chemistry. It's basically describes on the metal and ions chemistry, sir.
Yes, first is inorganic is periodicity. What is
Yes, sir.
periodicity? What the
In
basic application of periodicity?
Sir, in periodic table, the elements are arranged on the basis of their atomic number, sir.
Yes, what the basic difference modern periodic table and Mendeleev periodic table?
Sir, in modern periodic table, as I said, the elements are arranged on the basis of their atomic number. But in the Mendeleev periodic table, the elements are arranged based on the mass number. For so this is
Yes. Yes, how many elements present in periodic table presently?
sorry, sir. I have cough. Sir, 118, sir.
Yes, periodicity is what the basic difference? S block, P block, D block, F block element.
Sir, block elements are divided on the basis of their last electron configuration or the last electron enter into the which orbital. For like s orbital, the last electron of s orbital atoms elements are entering into the s subcell, and for p block the last electron of the elements are enter into the p, and like for d its last electron enter into the d, and based on this it can be divided into four blocks: S, P, D and F blocks element.
Yes, first is S block element. Yes, alkali metal and alkali earth metal, alkaline metal.
Alkaline
What
earth
the basic
metal.
difference?
The S block elements have special properties like they have a last cell electron enter into the s orbital, so they have very low ionization energy. For like alkali metal, here the last subcell configuration is S1, so the one electron can easily remove and we can apply less ionization energy, and most of the s block elements are metals, so these are the special properties.
Yes, next is a P block element.
Like here in the p block element, as I said, the last electron enter into the p subcell. These are the metal, these some are down the group are some metals are there and non-metals also there, and metalloids are also present in the p block elements. So some semiconductor properties are showing from the p block elements like silicon, germanium, all these, and they have very high ionization energy as compared to s block elements.
Yes. Next D block element.
The d block elements are the transmetals elements. They their d subcell is present more inner to or more close to the uh, nucleus, though they show some um, contraction in size, and most speciality of d block elements are showing color because of the dd transitions and something. They show magnetic behaviors also, and most of the d block elements are from coordination compound
Yes.
because of their well vacant d orbitals.
Next is F block element, lanthanide and actinide. For the basic application.
So these are the mostly radioactive elements are present in these A block element, so lanthanide and actinide contractions. So here in normal S to P block, we observe that the size is decreasing from left to right, but in lanthanide or actinide series, the size is not much decreasing. Size is more decreasing from there because of the lanthanide and actinide contractions.
Yes. Next is IPSC nomenclature. What the basic IPSC nomenclature? IUPSC.
Sir, IPSc stand for International Union of Pure and Applied Chemistry.
Yes. Yes. What the main basic
Sir,
role of IUPSC?
IUPAC generally offers the nomenclature of the compounds. In all over the world, if I named some compound something or any other person named something else, so it's difficult to identify what is this. So IUPAC provides certain rules for the naming of the compounds. So it is universalized.
Yes. Next is chemical bonding. Yes, what the basic application of chemical bonding in inorganic chemistry?
Sir, chemistry is the bond formation. So in chemical bonding, we know how the and what type of bonds are present in the compound inside the compound. There is various type of bond like ionic bond, covalent bond, coordinate bond, metallic bonds. Which type of bond is present? It can be identified from chemical bonding. And through bonding, we can predict the geometry and shape of the molecules.
Yes, what is bond? Yes, bond you talk about the chemical bond, ionic bond. Yes, which one is bond is more stable? Ionic and coordinate, covalent, hydrogen.
The ionic bond is just interaction between the positive and negative charge species, but covalent bond is the sharing of or overlapping of the orbital, so it is more strong than other. And coordinate bond is just donation of a pair of electron to a vacant orbital of another acceptor atom, acceptor species.
Yes. Next is octet rule. What is octet rule in chemical bonding?
The octet rule refers to the stable 8 electronic configuration of the outermost shell. It's similar with the Nobel gas configuration.
Any drawback limitation of octet rule?
Yes, sir. Octet rule cannot explain the Lewis acid species like AlCl3, how they don't have 8 electron in their valence shell, but still they are stable. It cannot be seen by octet rule.
Yes. Next is Fajan rule.
Sir, Fazan's rule tells about the bond is not purely ionic, not purely covalent. Fazan's rule tells the polarizability of the group and polarizing power. Based on this, it can be the covalent bond also can behave like a ionic because of its polarizing and polarizability power.
Yes. Next is Vesper theory. First one is Vesper theory. Valence shell electron pair repulsion theory.
Electron pair repulsion theory, sir.
Yes. What the basic application?
Sir, from BSc pair theory, we can predict the bond angle and the shape of the molecules, like for water molecule. Here water molecule have band shape, but if we observe its hybridization, it is sp3 hybridization, so it should be tetrahedral structure, and tetrahedral, its bond angle should be 109, but we observe that its bond angle is less than this. This is happens because of the two extra lone pair present in the water, which feels repulsion from each other. So the bond angle get decreases. This can be explained by VSE pair theories.
Yes, you talk about hybridization. Yes, what is hybridization? How many type of hybridization?
The hybridization is the intermixing of the orbitals, sir, and they produce a different type of hybrid orbital which has different property from that their parents orbitals, like various type of hybridization: sp hybridization, sp2 hybridization, sp3, sp3d, and based on the hybridization the structure, I can predict the structure and geometry of the compounds.
Yes, what the difference geometry and shape?
So geometry refers to the spatial arrangement of the compound, for water, its geometry is tetrahedral, sir, but its shape is bane shape. Bane shape means how the water molecule looks like. It refers to the shape.
Yes. Next is atomic orbital, molecular orbital. What the basic difference?
The atomic orbitals are the orbitals present in an atom, like s orbital, p orbital, d orbital, but molecular orbital are forming by the intermixing of the atomic orbitals. They behave different, like molecular orbital, we have sigma orbitals, pi star. This type of orbitals are formed after intermixing of the atomic orbitals.
Next is MOT.
MOT is molecular orbital theory, sir. It is the till now it is the most updated and accepted theory. It's explain the uh, formation of molecular orbital, and from this, uh, from BSCPR and BVT, we can determine the shape, structure, geometry, all these things. But the molecular orbital theory explains the magnetic property of the compound. The compounds are magnetic, paramagnetic, diamagnetic. Based on the molecular orbital theory, we can say that.
Yes. Next is hydrogen bonding.
Hydrogen bonding are the special type of bonding. It can be formed between the most electronegative element, like oxygen, fluorine, and nitrogen, and hydrogen. It is a non-covalent interactions, and it is very weak in nature.
Yes, next is inorganic section is acid base reaction. Acid base.
Yes, sir.
What is acid base concept? Arrhenius, Rostand,
Mm.
Lewis.
Yes, sir. Various concepts are there for identifying acids and bases. According to Lewis, sir, the compound which has a pair of lone pair to donate. These are bases, and acids are the species which can have a ability to accept a pair of electrons. These are called Lewis acid and Lewis bases. And according to Bronsted, the species which can able to donate H plus ion are acids, and the species which are able to donate OH minus ion are bases. And the third one is the species which are able to donate H plus are acids, and the species which are able to accept H plus are bases. Based on these theories, we can identify acid and base.
Hard acid, soft base, hard base. Yes. What the basic
Yes,
difference?
sir. Hard acid and hard base are based on the HSAB principle. Hard acids are the small in size and high charged species, and mm, bases are larger in size and less charged anions are the.
Yes, next is nuclear chemistry. Nuclear is the physical part. Yes, S block, P block, D block, and F block element.
So can you repeat?
Yes, inorganic chemistry, periodicity, chemical bonding. Yes, basic. Yes, next is coordination chemistry. Yes, what the basic application of coordination on OMC? First is coordination.
Sir, coordination chemistry is the study of the complex formation of the coordination complexes. Coordination complexes are formed between the metal ion and the uh, ligand by through the coordinate bond by donation of a pair of electron, and the metal accept this pair of electron in their vacant d orbitals. This type of bonding is studied in coordination chemistry.
Yes, coordination compound. Can you explain what the basic difference coordination chemistry and compound?
Sir, coordination chemistry is the formation of coordination compound, the behavior of the coordination compound, how its property, the whole chemistry behind the coordination compound is studied in the coordination chemistry. And coordination compounds are the compounds which can be formed by coordinate bond.
Yes, first is Werner theory. Yes, what the basic application of Werner theory?
Sir, Werner theory. Sorry, sir. Uh, Werner theory uh, gives idea about the. Uh, mm, sorry, sir. I forget exactly. I
Werner theory
think the
defines
name.
primary and secondary valency.
Sorry, sir. Werner's theory tells about the primary and secondary valencies of the coordination complexes. Like primary valencies are ionizable, secondary valencies are not ionizable. Primary valency tells about the oxidation states, and secondary valencies tells about the geometry around the complex.
Yes, first is ligand. What is ligand and how many type of ligand?
The ligand are the species which can donate a pair of electrons to the metal centers. Ligands are various types like monodentate ligand, bidentate ligand, ambidentate ligands, polydentate ligand.
Yes, first is ambidentate ligand.
So ambidentate ligands are those ligands which has the ability to donate from multiple sites, but at a time it can donate through only one sites. For like SCN, it can donate from S site, sulfur site also, or from nitrogen sites also.
Next, bridging ligand. What is bridging ligand?
The bridging ligand are those ligands which can uh, 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 form bond between two metals. They have multiple donation sites. They can simultaneously donate to the two metal centers. Like chlorine. Chlorine, while act as a both monodentate ligand and bridging ligand. For monodentate ligand, it can donate one electron and form bond with the metal, but while bridging, it can donate three electron to the metal centers.
Yes. Next is symmetric and unsymmetric bidentate ligand.
Yes, sir. Bidentate ligand means it can donate from two sides. Like ethylene diamine as a bidentate ligand, it can donate through two nitrogen atoms. Symmetric means it's a center of symmetry from. If we pass a plane, then it can be divided into two equals half, or they have the same donor site on the both.
And next, move on. Isomerase. Yes, what is isomerase? How many types?
Isomers are the Isomers are the species which have same chemical formula but different geometry around the space. And various type of isomerisms are there. Like in coordination chemistry, we saw various type of isomerism, especially stereoisomerism and constitutional isomerism. In stereoisomerism, two types of isomerism: optical isomerism, geometrical isomerism. In constitutional isomerism, uh, these are the isomerism.
Yes, what the basic difference organic and inorganic isomerase? Basic difference.
Sir, in organic isomerism, we generally more focus on the stereoisomerism, like optical and geometrical. But in inorganic isomerism, various other types of isomerism we observe, like linkage isomerism, ionization isomerism, coordination isomerism. These are the special type of isomerism which are not observed in the organic isomerism.
Yes, structural isomerase, ionic hydrate linkage, coordination, coordination position, ligand and polymerization. Yes, can you define the basic difference?
Sir, different isomerism.
Yes.
Sir, in coordination isomerism, the coordination pairs should be interchanged between two. And in linkage isomerism, the donor site of the ligand can be interchanged. Like for SCN ligand is present in some isomer, it was donated through sulfur, and in other isomer, it donated site from nitrogen. These are, and hydrated isomerism, it's shown for the water molecules, the complex having hydrated water molecules. Uh, Sometimes let three hydrogen molecules are outside the coordination sphere, and in other isomers it's inside two and outside one, like this.
Yes. Stereoisomery two type, geometrical or optical. What the basic difference?
Yes, sir. Optical isomer, in optical isomerism, sir, the bond can be interconvertible, and the isomer is basis on the optically active, but in geometrical side, the bond cannot be broken. For like cis and trans isomerism is the geometrical isomerism. If I take the ligand complex like AABB, if AA are both same site, then it is cis isomers, and if AA are on the different side, it was trans isomer.
Yes. Facial and meridional.
So facial and meridional isomers is shown by A3, B3 type of molecules. Here, if 3A are present on the one face of the uh, octahedral face, then it was facial isomer, and if it was not, then it was meridional isomer.
Yes, optically active inactive compound. What the basic difference?
Sir, optically active inactive is based on the rotation of the plane polarized light. Mainly, it's depend on the plane of symmetry. If plane of symmetry is present in the molecule, then it was mostly optically inactive. If POS is not present, then it is optically active molecules.
Yes, good.
Thank you, sir.
Next, move on. Theories for metal ligand bonding in coordination. First is VBT. What the basic application?
Sir, in VVT, valence bond theory says that only the bonding between the valence orbitals, like it's only say the inert and labile complexes, uh, this type of theories, but cannot explain the spectra and the magnetic properties of the molecules.
Yes, any drawback of VBT?
Yes, sir, the drawbacks are it cannot explain the spectra of the coordination complexes. It cannot tell about the magnetic behavior. It cannot explain the splitting of the